real quick background on what we're doing here. So Tilt, a lot of people here are familiar with it. It was introduced back in like September. Edwin was a big voice for that, and a lot of people mobbed on it, jumped on it, started looking at how to use it. It's a fantastic tool. We've discovered a use for it on that I wanted to demo and show how we're using it to help build out some new services and run their existing services. So some background. It was introduced back in September. We worked with it in the Prism dev workstream. So we were standing up Prism. We needed a way to stand up this Kubernetes app that they had built upstream in Prism that had many services, like 3 different databases, a bunch of stuff. So we looked at Tilt for doing that. We found K3D, started working with setting up a template inside K3D that would let us stand up this cluster and deploy all these things to Tilt. Started with just a template file that we then kind of plugged into, went into a bash script, start manipulating stuff, a Python script, start manipulating it more because we were dealing with arrays. Finally landed on this Python script here. Sorry, this is in the way. Don't save. There we go. So it's a lot of Python, and it is definitely something that could be trimmed up and work a little better, but it is functional and simple and takes a couple of parameters that you manage in a config file to stand up a cluster for local development very, very quickly. So let's demonstrate that. So this is a little script that I've got to show me current running containers. So if we do UV create cluster, well, first let's show the config. So this is going to show you what config it's going to apply to K3D. So here is the K3D configuration, app configuration, the settings that it's pulling from this config file, and then the K3D config that the app built to provision this cluster on your local machine. A few things we can touch in here. We've got an authenticated registry because the client uses a private registry harbor that they're hosting for a lot of the images. So we need this cluster to be able to access it. I've got environment variables set up with the credentials. The app creates a config for those credentials for K3D to be able to talk to it. We've also got some local data folders defined here that allow the cluster to have persistent data. So across cluster teardowns and buildups, you can maintain your data for the apps that you're using within it. We've got some K3D config options here, and overall pretty simple one. Let's go ahead and stand it up and watch the process. All right, so it shows you that. It's doing something in the background. In a second, it's going to prompt me here, right, for my password. So reason it needs this script actually updates your host file so that you can talk to the end cluster registry from your local machine. It's a workflow that is necessary for some app development where you need to develop an image locally and get it into that cluster. So that is what we need the sudo access for, so it can access your host file. And then you can see up here, we're starting to get some containers running these K3D, this cluster. All right, so we've got a cluster created successfully. You can see it up here. We open up Lazy Docker and see some logs, see some information, what's going on. Everything is up and running. Just with a single command, we've got a working cluster with all of the configurations that we've specified here. All right, so what is next? Right, it does pull in some environment variables, resource allocation, cluster deployment. Right, okay, so now we've got this cluster. Let's start talking about how we can start pushing things into it. Tilt configuration, this is the config that the app is reading. So right now it doesn't have anything applied to it. So let's do a tilt up, and it's going to run tilt. And if we go over to the tilt interface, I know, okay. We need to switch to the local cluster. Let's try that again. Killing me tilt, no resources found. Okay. We need to enable a single resource. Let's turn on the example tilt file. So this config is managed or monitored by tilt and is hot reloaded. So once we save this, see tilt picks up the change. And there we go. We've got a deployment inside our Kubernetes cluster. Let's down a little smaller, cancel that, and let's open up K9s so we can see the pod. There we go. We've got our hello world cluster, and in tilt, if we look at it, got a nice button here. UI. There we go. We just deployed our cluster, loaded an example file into it. Let's load in some additional tools into the cluster to help local devs like debug, see what's going on, and get a little information about what is going on in this local infrastructure they're running. So we're going to enable those, save that, come back over to Tilt. All right, so now we've got some cluster management tools spinning up. You can see them here in K9 starting to spin up. So there are two tools here that we've implemented, Headlamp and Netdata. Very simple integration into the cluster. We've got a single tilt file here that the base tilt file has imported in based on the config settings, and it configures everything about Netdata. Same here for the headlamp tilt file. This is everything we need to run headlamp and get it up and running. So let's have a look at headlamp. All right, it's green. We've got a button here we've added. We need to authenticate into headlamp. So let's copy the token, open up this, paste in the token. And now we have a web UI. For those that don't want to deal with CLIs or need just a different interface, you've got everything running inside your local cluster. You can view it from here. And let's check out Netdata. Let's see what's going on over here. So all of this is green. We've got it all deployed. Okay, so now we've got everything we need to know about our cluster here running inside our local machine. Lots of stuff here that you can use for debugging, all of the different containers that are running, the resources being used by the cluster. Really handy for us when we were debugging the Prism workloads, because those clusters and those databases were using a lot of resources and needed to be pared down to get it to run on people's local machines. So with just a couple of config lines, now we've got all these tools available. And let's go ahead and start deploying some actual apps that we're going to use. So first, we're going to install our Postgres tool that is in the cluster. Let that get spun up. And you can see Tilt, we've set it up here so that Tilt, we've got some extra tools for working with this Postgres cluster, that Postgres service that we're working, and Tilt is waiting for it to stand up before it tries to actually stand up the tools that are going to talk to that Postgres. So, all right, those are up and running. Let's go back to our config. So one of the aspects of this app that is really helpful for local development, you're running everything from this central Tilt Hub repo. And if you want to run multiple applications at the same time, which is the use case that we needed, you just need to include different tilt files, and the tilt file will import all of them from the config file, do it all hot reloaded. So as soon as we save this, we'll see the logs, setting up Postgres, and where's our recipient service? All right, we've got our recipient service starting up. So recipient service is a new app that we're building out on as part of the Strangler pattern for some of the existing services that are working in their, quite frankly, giant app. Their OneSuite app is huge, got a ton of services. You'll see them all in a second, and needs some help. That's why they hired us. That's what we're doing. The recipient service is the first one we're building out. It's serving as a template for all of the other ones. As we go through, right, there we go. As we go through, implement a Strangler pattern on the existing OneSuite and build out these additional domains one by one, we need this kind of access in this tool to be able to run the existing OneSuite app and these additional domains we're building next to each other in the same cluster in a way that can really speed up local development. Trying to do this on AWS cluster is going to be a lot more time consuming, waiting for things to deploy, waiting for feedback. If you can do it locally, you can do it fast. So it's really great for that fast feedback loop. So these guys are deploying. This takes a while because these are based on a .NET setups and need to be optimized for the build process. So that's why we're taking a little while. All right, there we go. All right, let's see. Let's redo this guy. It did not wait for the DB migrate. There we go. So now if we go, now we've got this recipient service running inside our cluster. We can see it doesn't have any data in it. A couple cool Tilt things we've done in here for this recipient service. We've added some interfaces for seeding test data into the application. So if we go here, you can see we've got logs from the recipient service that show that the seeds were run. If we run this guy too, 5 more. Now if we go back and refresh, we've got all this data. And bonus, because we've set up some of these cluster tools for interacting with our cluster, we can interact with that data using some more professional like tools. Let's see, databases. We're connected to the recipient data for the service. Here we go. All right, we've got all our data in here. We can access it. They are a very database reliant setup so having this kind of setup for their database admins and for all the devs that handle a lot of configuration through Postgres configurations, it's really important to have tools like this in the cluster so that they can maintain the existing workflows they're using and get away from those into better workflows. Let's see, one other trick we've got here. Let's go ahead and add the manifest for their existing apps. So we're gonna uncomment out this tilt file from a completely other project, completely other repo, save this and watch the cluster populate with a lot of stuff. There we go. So this is an example of, where are we running into image pools? Okay, so this is an example of standing up the multiple apps within the cluster to let devs work on both of them at the same time. So we still got recipient running and we've got one suite running in the same cluster so that they can start gluing them together, finding what parts of one suite recipient is going to take over, making those local changes happen in real time. Tilt will upload them, update the apps in the background so that developers can work really quickly to pull apart the old app and Strangler in the new recipient app. This setup gives them a one-line command to stand up their cluster, a very simple config file for them to determine what they want to be working with, and a really fast feedback loop for working on multiple aspects of apps at the same time.